With what we have seen so far, you might get the impression that cross-site scripting is a server-side problem. But is that really true? Unfortunately not. JavaScript running in the browser can also modify the contents of a page. This JavaScript code can also use untrusted data and insert it into the page in an insecure way. So, this JavaScript code will also need to provide the proper context information to the browser. Such client-side XSS attacks are known as DOM-based XSS. Before we dive into the details of DOM-based cross-site scripting, let's see what the flow of this attack looks like. First, the victim's browser loads a page from the BeerSafe application. Here, the page only contains legitimate data and code. The browser renders the page and executes the script code. A DOM-based cross-site scripting attack occurs when legitimate code modifies the DOM in an insecure way. Here, the code will take a piece of data from the URL and insert it into the page. But because the attacker can control the data in the URL, he can trick the application into injecting script code into the page. When the legitimate script code injects the data into the page, the browser processes it. The browser encounters the injected script code and executes it. Why would legitimate script code take untrusted data and insert that into the page? Take a look at the following code example. The page contains a component with 3 tabs. To enable linking to a particular tab, script code uses the identifier in a fragment of the URL. As you can see on the right, the identifier is used by the script code to display the correct tab. To exploit a vulnerability, an attacker simply needs to attach a payload to the fragment in the URL. The legitimate script will pick it up and insert it into the page. Note that this example is a reflected DOM-based XSS attack. But make no mistake, stored DOM-based XSS attacks exist as well. What's even more special in this scenario is that the payload is part of the fragment of the URL. The fragment is intended for client-side use only and is not sent to the server as part of the URL. This means that the server never sees the payload of the attack. Server-side defenses are useless against DOM-based XSS attacks. So then, how can we eliminate DOM-based cross-site scripting vulnerabilities? The best way to prevent DOM-based cross-site scripting vulnerabilities is to use the proper DOM APIs. These APIs offer safe functions to create and insert elements. They offer a way to put data inside an element without the risk of causing a confusion between data and code. Take a look at the example here. The left shows a string containing both data and code. When the browser parses this string, there is no context information, so we have an XSS vulnerability. The snippet on the right uses the proper DOM APIs. In every step, the browser gets implicit context information. Creating an element generates code. Setting a value as the text content of an element generates data. Because of this context information, the browser cannot be tricked into interpreting a piece of data as code. Of course, using the proper DOM APIs is not always possible. In those cases, you can fall back on traditional XSS defenses. Untrusted data can be encoded for the right context before inserting it into the page. Various client-side encoding libraries support encoding of data for different contexts. Alternatively, client-side sanitization libraries transform untrusted HTML code into safe code. One of the best client-side sanitization libraries out there is DOM Purify. You may think that DOM-based cross-site scripting vulnerabilities look strange and exotic. But make no mistake, they are prevalent and dangerous. A recent study of the Alexa top 5,000 websites has shown that at least 9.6% are vulnerable to DOM-based cross-site scripting. And if these major sites already fail to prevent DOM-based XSS vulnerabilities, then imagine what this means for the rest of the web. To conclude, cross-site scripting is a widespread and common vulnerability. XSS occurs when untrusted data is inserted into a web page without the proper context information. Here we have seen how payloads can be injected on the client side, a problem known as DOM-based XSS. The best defense against DOM-based XSS is using the proper context-aware DOM APIs.